are all about, multi-step problems are all about reading. The math is all going to be things you know how to do. The most important part of getting a multi-step problem correct, of getting the correct answer, is to make sure that you're reading it closely and carefully. So remember yesterday we looked for words that meant we were adding or subtracting or multiplying or dividing. We looked at the question first, and we made sure that we figured out what step we had to do first before we could do any of the others. What did we have to know? Well, yesterday, in example 1, we had to know, what was it? How much she earned each week. We know, or how much she had at the end of each week. We knew she earned $8 and spent $3 every week. We knew there's 52 weeks in a year, and we were trying to figure out how much she has at the end of the year. So first, we had to figure out how much she had at the end of the week. She started with $8, she spent $3. How much did she have at the end of each week? Come on, guys. Listen, this is like a first grade problem. She had $8, she spent $3. How much did she have at the end of the week? Victoria, $5. Then because we wanted to know how much that was in a year, we multiplied that $5 times 52 to get how much she had at the end of the year. But we had to figure out how much she had at the end of the week first. Then in example 2, we had a problem about trophies. We knew there were 3 boxes of soccer trophies. Each box had 45 soccer trophies in it. We knew that there were 15 tennis trophies. We didn't know how many golf trophies there were, but we knew how many trophies there were in all. There was 170. So that first step was to find out how many soccer trophies there were. So we had to do 3 times 45 first, because we couldn't add it to the tennis trophies without knowing how many there were. Then, once we figured out how many soccer trophies there were, we added them to the tennis trophies. We still didn't know how many golf trophies there were, but we knew how many total there were. So we subtracted the number of trophies we knew from the total number of trophies to find out that there were 20 golf trophies. Then in the guided practice, number 1, we knew that Carrie had 20 bags of prizes, and each bag had 4 prizes in it. We didn't know how many there were in all in those 20 bags, but we knew there's 20 bags and there were 4 prizes in each. Then we knew she had a red bag with 13 prizes, and she had a blue bag, but we didn't know how many prizes there were. We knew she had 100 prizes in all. So remember first, before we could add the prizes from the 20 bags, we called them gold bags, to the prizes from the red bag, we had to find out how many prizes there were in the 20 gold bags. So we multiplied 20 times 4, because we knew each of the 20 bags had 4 prizes in it. Then we added that, which was what? What was 20 times 4? Let's see, what was 20 times 4? This is easy. You should be able to do this in your head. Kingston? 80. So we added the 20 bags prizes, the 80 prizes, to the red bag prizes, 13. We got 93 prizes, but we still didn't know how many prizes were in the blue bag. But we knew how many there were total. So we subtracted the number of prizes we knew from the total number of prizes to get 7 prizes in the blue bag. So we're going to keep working on problems like that today. We know there's going to be more than one type of operation we're going to do. We have to figure out what the operations are and which part we need to do first. So everybody, look at number 2. We have to read closely. We know how to do the math. The math is almost the easy part in these multi-step problems. It's just about reading and reading closely. So right now what I want you to do is read that problem on your own in your head. Carla, are you focusing? Were you listening to anything I just said? Because you didn't look like it. And I just told you to read number 2 on your own. And then you didn't do it. You need to focus. This lesson is going to be extremely hard if you're not focusing. Please have a seat and read number 2 to yourself. Make sure your camera is tilted down so I can see you and what you're working on. Thank you. I'm going to give everybody another minute to make sure that they've read number 2. Okay, now read it again in your head while I read it out loud. Each small dog at doggy daycare weighs 35 pounds. Each large dog weighs 60 pounds. There are 4 small dogs and 6 large dogs. How much do the dogs weigh altogether? So our question is, how much do the dogs weigh altogether? Now normally when we see how much, that means money. But do we see any money up here? No, but we do see an amount of something. What do we see an amount of up here? That we would also say how much sometimes. Zadie? Pounds. So much tells us our answer unit is pounds. Because would we say how much do the dogs weigh altogether and say something like 65 dogs? No, we would not. We would say 65 pounds. That's not the answer. But I just wanted to, this marker's not working. So you have to make sure that your answer unit makes sense to answer the question. Like it wouldn't make sense if somebody asked you how much do the dogs weigh altogether and you said 65 dogs. Does that answer make sense with that question? No, because can you weigh dogs? Like, can you say, oh, I weigh 72 dogs? Is that something you can say? No, you say I weigh 72 pounds, something like that. So we know our answer unit is going to be pounds. Whatever the answer we're getting, it's going to be pounds. Now we just have to figure out what our equation looks like. Remember, we're writing one equation for each of these problems. So how many equal signs should I see on this line? Show me. 1. One equation, 1 equal sign on the line. Now on our separate sheet of paper, we're going to have a bunch because remember, we rewrite the problem every time we find something new. So now, let's look at the problem. Let's find out the information we know. Sometimes it's helpful to take notes. So let's take notes on this problem. The first sentence says, each small dog at doggy daycare weighs 35 pounds. What does that sentence tell us? Don't tell me in the same words. Use your own words as best you can. Obviously, you're going to use pounds, dogs, and the number. But don't tell me each small dog at a doggy daycare weighs 35 pounds. Smith, what does that sentence tell us?
That every small dog weighs 35 pounds.
So let's make a note to ourselves. Small dogs equal 35. The abbreviation for pounds is lbs. I don't know why. I think it's because the Latin word for pound has an L and a B in it. Okay, so now we figured out what that first sentence is telling us. The small dogs, each small dog at a doggy daycare, they weigh 35 pounds. Now let's read the next sentence. Each large dog weighs 60 pounds. What is that sentence telling us? Cullen.
Large dogs weigh 65 pounds.
The large dogs weigh 65 pounds. So there's our note. So now we know the small dogs weigh 35 pounds, the large dogs weigh 65 pounds. I'm sorry, 60. 60 pounds, so make sure that says 60 pounds, not 65 pounds for the large dogs. Okay, now let's read the next sentence. There are 4 small dogs and 6 large dogs. What does that sentence tell us? What does that sentence tell us? Carla?
It tells us how many small dogs and how many big dogs they are.
Good. It tells us how many small dogs and how many big dogs there are. Carla, how many small dogs are there?
There are 4 small dogs.
So let's make a note
6 5.
that we know that the small dogs are 35 pounds. There's 4 of them. Carla, how many large dogs are there?
6 large dogs.
6. So now our notes tell us there's small dogs weigh 35 pounds and there's 4 of them. Large dogs weigh 60 pounds and there's 6 of them. Does that show us how to solve this equation? No, now we have to write our equation. What do we need to know first? Before we can figure out how much they weigh all together, What do we need to find out? Think about it. Before we find out how much they weigh all together, what do we need to know first? Michaela. Well, but how do we find that? Look at this situation. We know there's 4 small dogs and they weigh 35 pounds each. We know there's 6 large dogs and they weigh 60 pounds each. We want to find out how much they are all together. So what do we need to do first? Cullen.
We have to find the information.
Okay, think about the situation. Yes, we're already finding the information. Now that we have the information, what do we need to know first? In this situation, there are 4 small dogs and they weigh 35 pounds each. There are 6 large dogs and they weigh 60 pounds each. What do we need to find first? What information do we need to know? Zari, I'm asking for specifics in this problem.
We need to look for what our unknown is going to be.
Okay, I'm looking for specifics. What specific thing about these dogs or their weight or whatever, or this doggy daycare do we need to know before we can answer the question, how much do the dogs weigh all together? What do we need to know about the dogs, about the doggy daycare, about their weight, whatever? Smith.
We need to know how many pounds 4 dogs weigh and how many pounds 6 dogs weigh.
Well, 6 dogs, be a little more specific. You're on your way, but you're just missing a word. We need to know how much the Zadie?
The small dogs and the large dogs.
We need to, but together?
No.
No, we need to figure out how much the small dogs weigh, and then we need to figure out how much the large dogs weigh. Then we can figure out what to do next. Okay, how do we figure out how much the small dogs weigh? How do we figure out how much the small dogs weigh? Look, there are 4 small dogs. They each weigh 35 pounds. Carla, how do we figure out how much the small dogs weigh?
We will need to multiply 35 times 4.
Good. So 35 times 4 will tell us what, Carla?
30 times 4.
Don't tell me an answer, just what will it tell me?
It will tell us how much does the 4 small dogs weigh.
So 35 times 4 will tell us the small dog's weight. We have to know that before we can figure out how much they weigh all together. Well, we have to know how much the small dogs weigh by themselves. We also need to know what before we can move on to the next step. This will tell us how to solve how much the small dogs weigh. What do we need to do? What else do we need to do first? What else do we need to do next? Aaron.
We need to find the unknown of our
We're specifics. Do you notice how every time someone said something like that, I said, nope, that's not what I'm looking for. I'm looking for something specific. Does that tell me something specific to this problem? And have we even figured out what our equation looks like yet? So we can't put our unknown until we know what our equation, we don't know where to put it yet, until we find out what our equation looks like. What else do we need to know? 35 times 4 will tell us the weight of the small dogs. Listen for the pattern. What else do we need to know before we can find this final answer? Kingston.
The weight of the large dogs.
How much the large dogs weigh. Okay? How do we find out how much the large dogs weigh?
By multiplying 60 times 6.
By multiplying 60 times 6. Now those are the first things we need to find, right? We can't find out how much they weigh all together unless we find out how much the small dogs weigh by themselves and how much the large dogs weigh by themselves. We have to know how much the small dogs weigh all together and how much the large dogs weigh all together first. What do we use in an equation to tell whoever's solving it, solve this part first? What do we use? Come on, guys, we just did this yesterday, and we've done this like a bunch of times this year. Carla.
Apostrophes.
Not apostrophes. What are those? Starts with a P. What do they look like, Carla?
Parentheses.
Parentheses. There you go. So we know we have to figure out how much the small dogs and the large dogs weigh first. We have to do that first. We cannot answer the question, how much do they weigh all together, if we don't know how much the small dogs weigh and how much the large dogs weigh. Once we find that out, what do we have to do? What do we have to do with those two answers? What do we have to do? Once we find out how much the small dogs weigh and how much the large dogs weigh, what operation do we have to do to figure out how much they weigh all together? Victoria? We have to add them. Remember, we have weight and weight. Do we ever multiply the same units? No, every time we multiply, we have two different units. So if we have the same units, we know we're probably going to be adding or subtracting. But if we have the weight of the small dogs and the weight of the large dogs, and we're trying to put them all together, are we going to end up with a smaller or bigger number? Class?
Bigger.
Bigger. So we know we have to add. Now, is there anything else in the equation that we don't know? Is there anything else that we don't know? So that means, which part is our unknown? Is it part of the equation or is it part of the answer? Cullen?
The answer.
The answer. What would you like to use for a variable?
An S.
An S. Make sure your S's don't look like 5s. Okay, so now we know to find out how much they weigh all together, that is our answer. So that means we're solving for S. First, we have to figure out how much the small dogs weigh and how much the large dogs weigh. Then we add it together. So there's our equation. Do we solve it here? No. Let's go to our separate sheet of paper. And we're going to start with we already did number 1 yesterday. So we're going to start with number 2. And then we're going to rewrite our exact equation. Are we going to leave off this variable? No, do not leave off the variable, even if it's the answer. Do not leave it off, because remember, how do we know we're done? How do we know that we're done solving? Cullen?
When we get to the variable.
Well, but we have the variable the whole time. Excuse me. How do we know we're done solving a problem? Smith?
When we have a number on one side of the equal sign and the variable on the other.
Very good. We know we're done when we have a number on one side of the equal sign and a variable on the other. Otherwise, we're not done yet. So if we forget to put this, well, we might get confused and be like, am I done? I don't know. So we're going to go over to our separate sheet of paper and we're going to rewrite the equation exactly as it looks on the line. So we have 3 times 4 in parentheses plus 60 times 6 in parentheses equals S. We know S is going to tell us how much the dogs weigh all together. So that means, what is our unit going to be? We're going to have S equals a number, what unit? Sorry.
A number of pounds.
A number of pounds. So let's leave a blank and let's just go ahead and put our unit. Make sure to leave a blank. Doesn't matter if the blank is too big, but make sure it's not too small. Okay, so now we're going to solve. Remember, we always solve what's in parentheses first. If we have 2 sets of parentheses, does that mean we solve one, bring the other set down? No, we can solve both of them at the same time. So we can solve 35 times 4 and 60 times 6, bring down our plus sign, and bring down our variable. Okay, 35 times 4. Can we solve it sideways like that? Is that a basic fact? No. So to the side, we need to set it up and down. 35 times 4. Okay. Cullen, when we're doing single digit multiplication, what do we do first? What's step 1?
Multiply the ones.
Multiply the ones, which means we're doing what equation?
4 times 5.
4 times 5, which equals?
20.
Now, can I put 20 down here?
No.
No, I leave the 0 in the ones place, and what do I do with the 2?
Regroup the 2 to the tens.
Regroup the 2 to the tens place. Thank you. Okay, what is step 2 when I'm doing one-digit multiplication? Aaron? Multiply the tens, which means I'm doing what equation? 4 times 3, which equals? 12. Do I write 12 down here? No, because what do I have to do first? I have to add our regroup numbers. So 4 times 3 is, plus 2 is 14. Now, do I have a hundreds place to regroup that 1 to? No, so I can just leave it in the hundredths of my, not my answer, but my, what's the answer to a multiplication problem called? I can hear you.
Your product.
Product, good. So that means, class, 35 times 4 is
140.
140. Now I need to solve 60 times 6. Do I need to, can I solve that this way? Well, let's see, I'll pick this. Kingston, can I solve 60 times 6 sideways like this? Why not? We can. Why? What can we use to solve that sideways? What strategy can we use?
Well, 6,
What strategy? What is the strategy called? Victoria? Basic facts and patterns. Come on, guys, you have got to be loud. It's like almost 18 weeks of school. You've got to be loud. So I'm using basic facts and patterns, which means I'm counting the zeros where? At the end of my factors, because sometimes I may have more than that at the end. So at the end of my ones place, at the end of my factors, how many zeros do I have at the end of my factors? Which means what? I have 1 0 at the end of my factors, so what does that mean? What does it mean? If I have 1 0 at the end of my factors, what does that mean? Don't tell me you put the 0 wherever, just tell me what it means. Michaela. There's going to be a 0 at the end of my product. There's going to be one, if there's 1 0 at the end of the factors, there's going to be 1 0 at the end of my product. Now, what's the basic fact, Kingston? 6 times 6, which equals? Who can help him out? What is 6 times 6? Mason? 36. So I'm going to put 36 in front of my 0, 6 in the tens place, 3 in the hundreds place. So, class, 60 times 6 is?
360.
360. Now am I done? No, because I have 2 numbers and an operation on one side of my equal sign and a variable on the other. I need to get where I have 1 number with no operations on one side of the equal sign and a variable on the other. So, do I have to do the opposite like we had to do in example 2 and number 1 yesterday, where I had to like switch it around and change the operation? No, because I already have my variable by itself. I only do that when my variable is not by itself, but I don't have to worry about that because it's been by itself the whole time. So, I'm just going to solve 140 plus 360 and bring down my variable. Ethan, can I solve this sideways like this? Or am I going to have to regroup somewhere? I'm going to have to regroup somewhere. So let's go to the side and write 140 plus 360. And we're going to add. Ethan, add the ones place. 0 plus 0 equals. Now add the tens place. 4 plus 6 equals 10. Can I put 10 down in this tens place? No. What digit do I leave in the tens place? A 0. And then what happens with the 1? Can you tell me the math way? What is that word that means we carry it? It starts with an R. We regroup it to which place? The hundredths place. So we regroup the 1 to the hundredths place. Now we add the ones. 3 plus 1? 4 plus our regrouped 1 is 5. So class, 140 plus 360 is, Carla, please turn your camera on.
500.
500. Carla, please turn your camera on. Carla, you got to make sure it stays on because you've got to make sure you're focusing because this lesson requires a lot more focus than some of the others we've done, because you have to read carefully and closely. So, class, now are we done?
Yes.
How do we know that we're done? Carla.
We know that we're done because there's only an answer that
Look at the equal sign. What do we have on one side of the equal sign, Carla?
the answer
Well, we don't know if it's the answer, but we know we can look at it and see we only have one what?
product.
One number. Not necessarily a product, because remember, we added, so that's actually a sum. So we have one number on one side of the equal sign, and then we have what on the other?
A variable.
A variable. So we know we're done. Once we have one number on one side of the equal sign and a variable on the other, we know we're done. So that means S equals what, class?
500 pounds.
500 pounds. So, answer this question for me. How much do the dogs weigh all together?
500 pounds.
500 pounds. Okay, we will finish numbers, at least numbers 3, 4, and 5. Before we leave, after lunch and recess. So girls at home, come back at 12:35. And then we will finish this page. And then we may finish the back. I don't know. Okay?
Miss Phyllis.
Yes. Okay, so when we solved number 2, we had quite a bit of information. We just had to figure out, okay, what did we need to know first? Well, the problem asked us the question, how much do the dogs weigh all together? We knew there were 4 small dogs, and they each weighed 35 pounds. We made that note to the side. We knew that there were 6 large dogs, and each of them weighed 60 pounds. So to solve the problem, what we had to do first was figure out how much the small dogs weighed all together. And how much the large dogs weighed all together. And then we had to add it together. To find how much the small dogs weighed, we multiplied 35 pounds times 4, because there were 4 dogs. Each of them weighed 35 pounds. To find the large dog's weight, we took the 6 dogs and multiplied it by the 60 pounds each, and then we added them together. When we solved, we got 500 pounds. So now we're going to do the same thing with number 3, but it's going to have different information, a different situation. So everybody take a minute to read number 3 in your head to yourself. Be thinking, what do we need to know? What's the question? What do we have to do first before we can answer this question? Take another minute to read. You're reading number 3 to yourself. You're thinking about it. What does it mean? And now read it in your head while I read out loud. Susie has track practice for 1 hour on Tuesday and 2 hours on Thursday. How many hours does Susie go to track practice in 15 weeks? Well, let's underline that question. How many hours does Susie go to track practice in 15 weeks? Do we know what our answer unit will be? Carla. Yes, what is our answer unit going to be, Carla?
Hours.
Hours, good. So we know whatever our answer is, it's going to be a number of hours. That's the first thing we need to find. Because that's going to help us find what is important, what we need to know first. Knowing the answer unit means, hey, we need to get to a number of hours. So now, let's read the problem again. Susie has track practice for 1 hour on Tuesday, and 2 hours on Thursday. What is the first thing that sentence tells us? Just pick up the one piece of paper, okay, and we can do the rest later. What is the first thing that sentence tells us? Zari.
That Susie practices track for 1 hour on Tuesday, and then 2
Wait,
hours
listen, Zari. The first thing. What is the first thing that it tells us? Don't tell me everything, just tell me the first thing that sentence tells us.
It tells us that 1 hour that she runs track for 1 hour on Tuesday.
Okay, so let's take notes. We know that Tuesday is 1 hour. The abbreviation for hour is HR. A lot of these units of measurements that we're working with have abbreviations. So we know that on Tuesdays, Susie practices for 1 hour. What else does that sentence, what's the second thing that sentence tells us? Michaela.
And she plays track for practice for 2 hours on Thursday.
So on Thursday, she practices 2 hours. Then our question says, how many hours does Susie go to track practice in 15 weeks? So we know Tuesday she practices 1 hour. Thursday she practices 2 hours. We want to figure out how much that is in 15 weeks. So what do we need to solve first? Tell me, in this situation, what is the first thing that we need to know from these numbers? We know she practices 1 hour on Tuesday and 2 hours on Thursday, and we're trying to find out how much that is in 15 weeks. What do we need to know first? Smith?
We need to know how many hours she practices in 1 week.
Very good. We need to know how many hours she practices in 1 week. If we don't know how many she practices in 1 week, how do we know how many she practices in 15 weeks? Can we solve that? No. So Smith, how do I solve how many hours she practices in 1 week?
You can add the 2 hours together and multiply it by 1.
Wait, hold on. So to find out how many she practices in 1 week, we know she practices 1 hour on Tuesday and 2 hours on Thursday. So there's only one step we need to do to figure out how much she practices in 1 week. What is that?
Add 1 hour and 2 hours together.
We add 1 hour plus 2 hours. Because what is that going to tell us, Smith?
It's going to tell us how many hours she practices in 1 week.
So 1 plus 2 tells us 1 week's practice. Okay. Now we need to know, what do we do with this 15? Well, we're trying to find out how much she practices in 15 weeks. This tells us how many she practices in 1 week. So what do we need to do with that 15 to show that it's not just 1 week, it's 15 weeks? What do we need to do with that 15? Are we adding it? Are we subtracting it? Are we multiplying it? Are we dividing it? Carla.
We are multiplying 15 with the number that we get from 1 plus 2.
Good. We are multiplying by 15. Why are we not adding? Why are we not adding? Come on, guys, think. Don't just give me that look like. Think. Smith, why are we not adding? Focus.
Because if we added 15 to the number we got from 1 plus 2, that would basically be saying how many hours she practices in 15 days.
Not quite 15 days, but you're on the right track. Can we add weeks and hours? I'm sorry, can we add weeks and hours? Can we add those two things together? No, we can only add or subtract the same units. Also, we know, which part do we have to solve first? Do we solve 1 plus 2 first or 2 times 15 first? Cullen.
1 plus 2.
1 plus 2. 2 times 15 would just take 15 weeks and repeat it twice. Do we need to do that? No, that doesn't do anything for us. We have to add 1 plus 2 first to get 1 week's practice. And we're multiplying because when we multiply, what are we doing? We are doing what kind of addition? Carla? We're taking a group. When we multiply, we're taking a group. Are we putting it together with another group?
Yes.
No, that's adding. When we multiply, we're taking a group and we're doing what with it, Michaela? Repeating it. So we're taking 1 week of practice and repeating it 15 times. Because how many weeks are there, Michaela? 15. So each of those 15 weeks have some time spent practicing. So we take those hours that she practices in 1 week and we repeat it 15 times. Remember, multiplication means we're repeating a group. Adding means we're taking 2 groups and putting them into one. Can we take hours and weeks and put them in one group? Would that make sense? No. Because it would still be 15 weeks and then a number of hours just next to each other. Does that make sense? No. Is there anything else that we need to include in this on this side of the equal sign? Carla?
A variable.
Well, do we need to put it on? Is there anything else? Is a part of our equation what we don't know, or is it the final answer that we don't know? Zari?
The final answer, that's what we don't know.
Okay, so do we need to put anything else on this side of the equal sign?
No.
No, we know every part of our equation because we know Tuesday's 1 hour, Thursday's 2 hours. Those numbers together will tell us 1 week, and we know we're repeating it for 15 weeks. There's nothing else that we need to put on that side of the equal sign. So, Zari, what do we need on the other side of the equal sign?
A variable.
A variable. What would you like the variable to be?
A J.
A J. And Zari, we know our answer unit, right? What is our answer unit going to be?
Hours.
Hours. So we know we're going to have a certain number of hours. So let's go ahead, save yourself space, and let's put hours. Now, are we going to solve it right here, class? No, there's not anywhere near enough room. So go to your separate sheet of paper. If you need to use the back, go ahead. Start with number 3. Make sure to number your problems on your separate sheet of paper. And then we're going to rewrite our equation exactly as it appears here. Are we going to leave off that variable? No. Because we're trying to get to a point where we have one number on one side and a variable on the other side of our equal sign. Okay. The parentheses tell us we solved that part first. Me. Michaela, 1 plus 2 is what? 3. Is there anything else up here that we can solve yet? No. So what do we need to do with times 15 and equals J? Bring it down. So now we have 3 times 15 equals J. Mason, what do we do next? Are we done?
Yes.
No, why? When we know we're done when we have what on one side of the equal sign and what on the other?
An answer.
Not an answer, but we have how many numbers on one side?
2.
Think about this is a pattern. We've done the same thing. We know we're done when we have what, Cullen? Listen, Mason, you need to be listening to this.
A number on one side of the equal sign and our variable on the other.
How many numbers should we have on one side?
1.
1. And we should have what on the other side of the equal sign?
A variable.
Should we have any operation symbols?
No.
No. So Mason, are we done yet? Do we have one number on one side of the equal sign with no operation symbols and a variable on the other side?
Yes.
This is one number?
No.
No. So are we done?
No.
Mason, so just look. I hear that question at the end of your voice. Your voice should not go up. You need confidence. You can look. How many numbers do we have on this side of the equal sign?
Sure.
this side I'm pointing to.
Oh,
Is 3 times 15 one number? No. Do we have any operation symbols on this side? Mason, come on, think. Don't do that. That's not helpful at all. Not even a little bit. Operation symbols are the symbols that mean adding, subtracting, multiplying, and dividing. So do we have a multiplication symbol on this side that I'm pointing to of the equal sign? And we have how many numbers? 2. 3 and 15. So are we done? Michaela? No, because how many numbers do we need on one side of the equal sign? How many, and we need what on the other side? A variable. Mason, we have 2 numbers and a operation symbol on this side of the equal sign. We're not done until we only have 1 number and no operation symbols. So we can't be done yet because we still have to solve 3 times 15 and then bring down equals j, because we need 1 number and no operation symbols on one side of the equal sign and a variable on the other. Right now we have 2 numbers, 3 and 15, and the operation symbol for multiplication. So we can't be done. So now we have to solve. Mason, is this a basic fact that we can solve sideways like this? No. So where do we need to solve it? Confidence. Just to the side somewhere, right? How? Do we solve it sideways? How do we solve it? Up and down. So 15 times 3. The steps, now we need to follow the steps for 1-digit multiplication. Step 1 is to multiply the, so we're doing what multiplication problem? 3 times 5, which is 15. Can we put 15 in the ones place? Which digit do we leave in the ones place? What do we do with that 1? Regroup it to the tens place. Good. Now next step is to multiply the tens, which means we're doing what equation? 3 times 1, which equals? But do we put 3 down here? No, because what do we have to do next? Add our regroup number. So 3 times 1 is, plus 1 is 4. Remember, confidence. So you're 4, not 4. Do you hear how the question is in your voice? Confidence, no question in your voice. So Mason, that means 3 times 15 is 45. Now Mason, are we done? Yes, because why? What do we have on this side? How many numbers? 1. Do we have any operation symbols? Adding, subtracting, multiplying, dividing? No. And then what do we have on this side of the equal sign? Our variable. Anything else? Nope. So are we done? Yes. So that means J equals what, Mason? 45, which means, class, the answer to the question, how many hours does Susie go to track practice in 15 weeks, is what?
45
hours.
45 hours. So when you're solving these, because tonight you're going to have to do the homework on your own. So when you're solving these, you need to look for what you need to solve first. In this problem, we knew how many she had one day. We knew how many hours she had one day of the week, and we knew how many hours she had another day of the week. Did we know the total hours in 1 week when we first read it? Did it say she practices for this many hours in 1 week? No. Did we know how many weeks we were trying to find out she practices in? We didn't? Did we? We knew she was practicing for 15 weeks. So we knew we had to add 1 and 2 to get 1 week's worth of practice. Then we had to multiply it by 15 because we were repeating those 3 hours every week for 15 weeks to find our answer. So make sure you're looking for what you need to know first in order to get to the final answer. Figure out what you don't know. In this problem, we knew we wanted to find out how many she practiced in 15 weeks, which meant we had to repeat 15 times. But we didn't know how many to repeat each time, because we had a 1 and a 2. Well, which one do we repeat? Well, we have to repeat both of them, because that's how much she does in a week. So we just went ahead and put it together, the hours in 1 week together first. Otherwise, we'd have to do 1 hour times 15, then add 2 hours times 15. Both of those are not hard to do, but it's just extra steps. So it's easier if we just go ahead and figure out how much time she practices in 1 week and then repeat it for those 15 weeks. Please pay attention. Some of you are not in one equation, which means you'd have to put the parentheses around 15 times 1, then the plus sign, then parentheses around 15 times 2, then the equal sign and the variable. Okay, so number 4, we're doing the same thing. Warren, Lisa, and Tina went to the carnival. The table shows the number of points Warren won at each carnival game. Lisa won the same number of points as Warren. Warren, Lisa, and Tina won a total of 225 points. How many points did Tina win? So there's our question. How many points did Tina win? Do we know our final answer unit? Colin?
Yes.
What is it?
Points.
Points. So there is our answer unit. Okay, now let's read through this and figure out what each of these sentences mean. Focus, because this one's got a few steps that you have to follow. Warren, Lisa, and Tina went to the carnival. Does that sentence tell us anything important? No, it's just setting the scene. Can we do anything with carnival with no numbers with it? No, that just tells us why they're winning this point. Sometimes word problems do have extra information like that just to make it seem more real, like it could happen. So let's go to the next sentence. The table shows the number of points Warren won at each carnival game. So here's our table. Warren won 24 points banana bowling. Warren won 16 points doing toss and trade. Warren won 10 points doing rabbit race. I'd like to know what these games are. I've never heard of some of them. Banana bowling. No idea. So we know what? What does this table show? Zari.
It shows the games that he has played, that Warren has won at the carnival.
It shows, so it does show the game, but it more specifically tells us what that he's won.
The points.
So these are all Warren's points. So let's label our table to tell ourselves, hey, Warren won those. Nobody else that we know of but Warren. So Warren won all these points. Now our next sentence tells us Lisa won the same number of points as Warren. What does that mean? In your own words, what does that sentence mean? Zadie.
It means that Lisa has the same amount of points as Warren does.
So Lisa has the same amount of points as Warren. Do we know yet how many points Warren had? Can we figure it out? How can we figure out how many points Warren had? Kingston?
By adding 24, 16, and 10.
Good. By adding his points from banana bowling, which is 24, his points from toss and trade, which is 16, and his points from the rabbit race, which is 10. Do we know yet how many points Warren won? So that we can say how many Lisa won, because we know Lisa won the same amount of points. But do we know how many points that is yet? No. We can only have one equal sign. So can we solve this and then put Lisa's points? No. So what can we do to show that whatever we get to at the end, this happens twice? What can we do to show that this happens twice? Victoria.
We add that all together and then we times it by 2.
So what do we do to show that it happens twice? Take out the first part you said.
We multiply it by 2.
Very good. Awesome. We multiply by 2. Because in the end, we know that our final answer after our equal sign, do we know what's going to come after our equal sign in this problem? Look at it. Look for those patterns. Do we know what is going to come after our equal sign in this problem? So is it part of our equation on the left side of our equal sign, or is it part of our answer on the right side of our equal sign that is our variable? What is our unknown? Zari.
Our unknown is it's part of the answer what we're looking for.
There's a pattern, something we saw yesterday. We see total of 225 points, which means where does 225 go? On the left side of the equal sign or the right side of the equal sign? Colin.
The right side of the
The right side of the equal sign. Because we are trying to figure out, we know that Warren has this many points, Lisa has the same number, and then Tina has some points. All together, it's 225. Do we know how many points Tina has? Carla?
No.
No. So that is our what?
Variable.
That's what we're going to use our variable for. So, Carla, what would you like to show the variable for Tina's points? What letter would you like to use? Except for O, L, X, or T?
V.
V. Okay. Now, once we figure out Tina's points, what operation do we have to do with them? We know all together these 3 kids have 225 points. What operation do we have to do with Tina's points to find the 225? Victoria? We have to add them. We are going to put together Warren, Lisa, and Tina's points. We know Warren got 24 points, 16 points, and 10 points, so we had to add all those together. Then we're going to multiply that by 2 because we know Warren and Lisa got the same amount of points. So we could just add that number twice, but we don't know what that number is. So we're going to multiply it. Then we add, I keep wanting to say Victoria because it's a V, Tina's points. But now we need to put our parentheses. What do we need to solve first? Smith, let's see. It's kind of a trick question, but not really if you're really thinking about it.
We need to do 24 plus 16 plus 10 first.
Good. We have to add all 3 of those together. Why do we have to add all 3 of those together first, Smith?
Because so that we know the number of points Warren won.
Good. So if we add all 3 of these numbers together first, then we'll know Warren's points. Why are we multiplying by 2 after we find out Warren's points? Aaron. Well, it says Lisa had the same amount. And can we add her points when we don't know what they are yet? Can we add her number of points when we don't know exactly what number it is yet? No. But we know if we're adding something twice, like 6 plus 6, it equals the same thing as 6 times 2. 6 plus 6 is what, class?
12.
12.
6 times 2 is what, class?
12.
12.
If we do the same thing with does it equal the same thing as that? Carla, add the ones. 2 plus 2?
4.
Okay, there's a few. Okay, 4.
Zoe, you're on the video.
Sorry.
Carla, add the 10. 0 plus 0.
0.
Add the hundreds. 1 plus 1.
2.
Okay, now let's see if it's the same thing as 102 times 2. Victoria, multiply the ones. 2 times 2 is? Multiply the tens. 2 times 0 is? Multiply the hundreds. 2 times 1 is? Do we get the same answer? Yes. So we know whatever this answer is, if we multiply it by 2, it's going to be the same thing as saying Warren's points plus Lisa's points, because they're the same. Then we have to add Tina's points, and in the end, we have to get to 225 points. So, is there anything else that we need to add to our equation, or do we have it all ready to go? Is there anything else? Look at the problem. Some of you are just waiting for everybody else. Look at the problem. Is there anything else that we need to put into this equation? Or are we ready to solve? Ethan? Is there anything else in this problem that we have not put into our equation yet? No. So we're ready to Colin? Solve. We're ready to solve. So we're going to go to our separate sheet of paper, and we're going to write number 4, and we're going to write our problem exactly as it appears here. 24 plus 16 plus 10 in parentheses times 2 plus V for Tina's point equals 225. Smith, what do we solve first?
We solve 24 plus 16 plus 10 first.
Good. Now, should we solve that up sideways like that?
No.
No. So let's write it again, up and down to the side. So Smith, add the ones. 4 plus 6 plus 0.
10.
10. But we leave the 0 in the ones place, and we regroup the 1 to the tens place. Now we're going to add the tens. 2 plus 1 plus 1.
4.
Add our regroup number. 1.
5.
5. So, that means 24 plus 16 plus 10 is what, Smith?
50.
50. What do we do with the rest of our equation? Do we solve anything else yet?
No.
No. So we what do we do with the rest of our equation?
We bring it down.
We bring it down. So we're going to bring down times 2 plus B and equals 225. Okay. Zari, what do we do next?
We do 50 times 2.
We do 50 times 2. Can we solve that sideways, or do we need to set it up and down?
We can solve it sideways.
Why can we solve that sideways even though it's not a basic fact? What strategy can we use?
We can use patterns.
There's more to it. What and patterns? Colin?
Basic facts and patterns.
Do you hear her? Sorry? Basic
No, I
facts and
couldn't hear.
patterns. So you guys, even Colin, who's right next to her, if she's not talking louder, they can't hear. So make sure you can hear. So, Zari, what strategy do we use to solve 50 times 2?
Basic patterns.
Basic facts and patterns.
Basic facts and patterns.
So, the patterns, how many zeros do we have at the end of our factors?
1.
Which means what?
I couldn't hear you because I was still unmuted.
Which means what? We have 1 0 at the end of our factors, so what does that mean?
We're going to have a 0 at the end of the of our product.
Good, we're going to have 1 0 at the end of our product. Now, what's the basic fact?
5 times 2.
Which equals?
10.
So that means, how many points did Warren and Lisa win together?
100 points.
100. But now we need to figure out, okay, we need to bring down the rest of the equation to figure out how many Tina won. Uh-oh. We have a number and a variable on one side and a variable on the other. What do we need to do? Colin.
225 minus 100.
You forgot to.
Oh, plus V.
Not plus v.
Oh,
We're flipping it around. We need to get the variable by itself, right? So we're going to move this over, put the v by itself, and then change the operation. But can we change it like this? Can we just flip the 225 and the v? Can we do that? No. So we just have to move it around and make it work. So instead of 100 minus 225, what does it need to be, Colin?
225 minus 100.
Good. Now, our variable is by itself. So we just flipped it and changed the operation to the opposite operation. Would we ever change addition to multiplication or division? Would we ever change addition? I said this yesterday. Would we ever change addition to multiplication or division? No, we can only change it to the inverse operation. The inverse operation is the opposite. What's the opposite operation of addition? Class?
Multiplication.
Subtraction. Good. Not multiplication. Multiplication and addition are basically the same thing. But just multiplication means the addition's happening over and over again. Because remember, 15 times 3 is the same thing as 15 plus 15 plus 15. So can they be opposite? You're getting a bigger number both times, right? And you don't want to get a bigger if you're trying to find the opposite. The opposite of big is small. So that means you're trying the opposite. The inverse operation is one where you're getting a smaller number. Does addition give you a smaller number? Does multiplication give you a smaller number? So the opposite of addition is what, class? Subtraction. So now we need to solve. Colin, do we need to set this up and down, or can we solve it place by place?
Set it up and down.
Are we going to have to regroup?
Oh, no.
No. So we can basically do it in our heads, because are we going to have to do any regrouping?
No.
No. So let's solve it. Subtract the ones. 5 minus 0 is?
0. No, 5.
5. Subtract the tens. 2 minus 0 is?
2.
Subtract the hundreds. 2 minus 1 is?
1.
So that means 225 minus 100 is what, Colin?
125.
Are we done?
Yes.
How do we know we're done?
Because we have one number, we have 125 on one side of the equal sign, and we have a V on the other side of the equal
So we know we're done because we have our one number on one side of the equal sign, and we have our variable on the other. So that means, class, V equals what?
125.
Which means,
125
how many, the
points.
answer to the question, how many points did Tina win, is what, class?
125
points.
Now, some of you I can tell are really thinking. Some of you are not. And it means you're going to get home, you're going to get frustrated. I don't know. You have to think. You are able to solve all of these. What? You are able to solve all of these. Unless you just give up and say, I don't know how to do this. This is too hard. It is reading comprehension. Everybody in this classroom is a good reader. Just because you're putting numbers in with it does not mean that it's unsolvable. You just have to figure out what do those numbers mean. Just like when you're doing Wonder and you're putting different parts of a story together to put into one answer, you're doing the same thing. Because once you get to the math part, you know how to do all that. It's not even having us do double-digit multiplication. You just have to read the problem and figure out what you need. What do you need to know first? What do you need to do last? What is your final answer needing to be? Okay, let's look at number 5. We're going to read it out loud first, or we're going to read it together first. So read in your head while I read out loud. Yes, Victoria. What? What?
I need a pen.
Okay, well, how am I supposed to know that that means bank? Can you wait a minute, or do you need it immediately? Okay. So everybody look at number 5 and read it in your head while I read out loud. Mark bought 4 hats that each cost $8. He also bought a shirt that costs $14 and a pair of jeans. He spent a total of $68. How much did the jeans cost? So, we have our question. How much did the jeans cost? What is our answer unit going to be? If you are tuning me out while I'm saying this, just thinking this is hard, well, you're missing everything that you need. If you listen and you pay attention to what I'm saying and what your classmates say and what the question says, you will be able to do this. Some of you are really getting it. Those of you that are really getting it, I can tell you're listening. You're looking, you're focusing, you're reading closely. Those of you that are not getting it, every time I look up, you are not paying attention to what's going on up here or to what your classmates are saying. So make sure that you are listening. Just because your classmate is answering doesn't mean you can tune out and try to figure it out yourself. Don't try to figure it out yourself right now. When we're working together, you work with me and your classmates, not on your own. Do you understand? Okay. So we know the question is, how much did the jeans cost? What is our answer unit going to be? Smith.
Money or dollars?
Money, so a dollar sign. Because we see how much, and then we see dollar signs in our equation. So we know our answer unit is money. Let's look at this problem. Let's do this step first. Do we know if our final answer, the number on the right of the equal sign, do we know it, or is it going to be our variable? Look at this problem. It's a pattern. Raising your hand. Okay. Look at this problem. Do we know the number that is our final answer that's going to go on the right side of our equal sign, or is that our unknown? Kingston.
It's gonna be on the right of the
What is?
68.
So we know what goes here, right? We know it's not our unknown. It's 68. How did you know that? How did you know that the final answer to whatever our equation is 68? How did you know that?
Because it says he spent a total of 68.
So which word was your key word that told us, hey, that's going to go on the right side of the equal sign? What specific word told you that goes on the right side? That's the final answer of the equation. Total. So if you see total of something, you know it is almost always going to go on the right side of the equal sign. So that means our unknown is a part of what? Zari.
We know our unknown is part of our equation.
We know the unknown is the part of the equation on the left side of our equal sign. Do we know which part it is yet without going back and reading through? No. So let's go back and read through and see what we know. Mark bought 4 hats that each cost $8. What does that sentence mean? Carla.
It means that Mark had bought 4 hats that cost $8.
Do the hats cost... Oh, Carla, don't forget to mute yourself. Do the hats cost $8 total? So what does that mean? Victoria.
That each hat costs 8.
So how many hats cost $8?
I mean,
1. So that means we know 1 hat equals $8. But did Mark only buy 1 hat? How many hats did he buy? Zadie?
4.
4. So hey, it's kind of like that doggy daycare question where we know how much each item cost or how much each item was, but we had more than one of them. Let's keep that in mind when we're trying to find out let's go ahead and do that. So what equation tells us that he bought 4 hats for $8 each? You want to try? Ethan, what equation tells us that he bought 4 hats that were $8 each? What is that equation going to look like? We need to know how much. We need to know the cost of the hats, right? So what equation will tell us the cost of the hats?
Better taste, better nutrition, better eggs.
What does the equation look like? So what operation? What are the numbers and what operations that shows us how much the hats cost altogether? How many hats are there? He can do it. 4. If they cost $8 each, are we adding $8 to the 4 hats? Are we subtracting $8 from the 4 hats? Or are we multiplying $8 times 4 hats? And we haven't gotten to division yet, so we know it's not going to be that. Can we add hats? Can we add or subtract hats and dollars? No, so that means we have to be doing what? Multiplying. So we're taking the 4 hats and we're multiplying them by 8 because it's like we have 4 groups of $8. 1 hat is $8. Then we take it and we repeat it. The second hat is also $8. The third hat, we repeat it again, also is $8. The fourth hat, repeat it again, is also $8. So we're taking $8 and we're repeating it 4 times. Okay. He also bought a shirt that cost $14 and a pair of jeans. What does the first part of that sentence tell us? Let's see. Zari? Can't remember if you've answered recently. Zari, what does the first part of that sentence tell us? I know that sentence tells us more than one thing, but what does the first part tell us?
He bought 14 pair. Well, he bought a shirt that was $14.
So he bought a shirt that was $14. What do we need to do with that $14 to figure out the total, to get to the total of 68? Are we going to add it to the cost of all 4 hats? Are we going to subtract it from the cost of all 4 hats? Or are we going to multiply it by the cost of all 4 hats? Zari?
We're going to add it to it.
We're going to add it. Then the second part of that sentence says, and a pair of jeans. What does that mean? What does that mean? Michaela? Do we know how much the jeans cost? Do we need to know in order to get to our answer of $68? We don't? Yeah, so what do we need to show the cost of the jeans? We also know that's our question. So what do we need to show the cost of the jeans? Well, we need a what? A variable. What would you like to use for the variable? N. Make sure your N's look like an N. And then once we figure out how much those jeans cost, what are we going to do to the total cost of the hats, the cost of the shirt, to get to $68? Michaela? What are we going to do with the cost of the the jeans, once we find it, to get to $68? What operation? Addition. Because we're taking the cost of the hats, the cost of the shirt, and the cost of the jeans, adding them all together to get the total that he spent that day. Which of these parts do we need to solve first? What do we need to solve first? We can't finish until we solve one part first. What do we need to solve first? Zadie,
4 times 8.
4 times 8. Why do we need to solve 4 times 8 first?
Because if we can't solve 4 times 8, then we can't add 14.
Okay, well, why? Think of what the items. What are these items? What do we need to know before we can add the cost of the shirt and the cost of the jeans? What does this 4 times 8 tell us?
How much the hats altogether cost.
So, 4 times $8 tells us cost of the hats. Can we add the cost of the hats to the cost of the shirt and the cost of the jeans if we don't know exactly what it is yet? Can we use it to figure out the cost of the jeans if we don't know exactly what it is yet? Remember, can we have 2 unknowns in one problem? Think about what I said yesterday. Can we have 2 unknowns in one problem? No, we have to know one of them. Right now, the cost of the hats is unknown, but we have the tools to find how much it costs. We have enough information to find out how much the hats cost. We just don't know exactly how much it is yet. So we have the information we need. So is it technically an unknown? No, it's just we need to do a little more to find it. Okay, is there anything else that we need to put into this equation? No, we know we're trying to solve for n. We have to figure out how much the jeans cost. Do we know our answer unit? What is our answer unit going to be? Michaela? A $sign. Do we have to save space and put the $sign over here? No, because where does a $sign go when you're talking about money? Does it go in front of the number or behind the number? In front. Okay, good. So now, what do we automatically know we're going to have to do towards the end? Look at where the variable is. What do we automatically, and then look at when we solved for number 4, what do we know we're going to have to end up doing as our last step to solve? Zari?
We're going to have to subtract.
Well, we're going to have to flip numbers around and then find the inverse operation. We know we're going to have to flip some numbers around in the end and change the operation because we need to get this variable by itself. So, let's go over to your separate sheet of paper. If you need to use the back or a new sheet of paper, go ahead and do that. Oops, I accidentally erased part of our notes. So, we're on our separate sheet of paper. You have number 5. And we're going to write our equation exactly as it appears. 4 times $8. There are 4 hats. They're each $8. So 4 times 8 tells us the total cost of the hats. Plus $14 for the shirt. Plus something for the jeans. Equals a total of $68 spent. So we need to figure out what this N is in order for him to have spent $68. Because we know he spent something on the jeans. Would you ever go to a store and get jeans for $0? Ever? No. It's just not a thing unless you stole them. Well, Mark is not a robber. He's not a thief. He paid for them. So we have to figure out how much he paid for them. Okay. Zadie, what do we solve first?
4 times 8.
4 times 8. Because, why do we know that no matter what?
Because if we didn't
Look at the
know-
symbols. We know this from the symbols. We already figured out why we had to solve it first. Why we had to put these symbols. But say this was just a problem. There was no real world equation. There was no real world problem to it. How do we know we have to solve 4 times $8 first?
Because if we didn't solve it first, we couldn't add 14.
Well, but look at the problem. Look at the symbols. What is here that tells us we have to do that first? Michaela? Because it has parentheses. Okay, Zadie, what is 4 times $8?
$32.
$32. Do we solve anything else yet? Okay, we're going to solve this really quick. Do we solve any of the rest of this yet?
No.
No, so what do we do with the rest of the equation?
We bring it down.
We bring it down. So we're going to bring down plus $14 plus N equals $68. Okay, so now we have $32 plus $14 plus n equals 68. Carla, what do we do next?
We add 32 plus $30.
14, not 40, but 14.
13.
So, do we need to set this up and down, or can we add it place by place in our head?
Place by place.
Good, because we don't have to do any regrouping. If we had to redo regrouping, do we solve it in our head? No, because what might happen if we try to do regrouping in our head? Smith. Smith,
We would make a mistake.
you might make a mistake. You might forget about that regroup number. Okay, Carlos, let's add the ones. 2 plus 4.
6.
Add the tens. 3 plus 1.
4.
Bring down our dollar sign. And then do we solve anything else over here, Carla?
We bring down the others.
We bring down the rest of the equation. So we're going to bring down plus n equals $68. Thank you, Carla. You can go ahead and mute yourself now. Uh-oh. Now we're to the point where we have nothing that we can do on this side of the equation, and nothing of the equal sign, and nothing we can do on this side of the equation. Because we can't add 46 plus n. We don't know what n is. We don't have our variable by itself, and we have more than one number. So what do we need to do next? Zari.
We would do 68 minus $68 minus $46
Don't forget the whole equation.
equals n.
Good. So we flip the numbers around and change it to the opposite operation. When we are changing addition to subtraction, we just have to make sure that it works. So we can't just flip $68 and n, because we can't do 46 minus 68. It's not possible. So we just need to flip it around, change it to the opposite operation, and make sure it works. Thank you, Zari. What are we going to do next? Mason.
Subtract
68 times 46?
68 minus 40.
Good. And then what do we do with the equals n? We bring it down. Oops, I need to bring it down more than that. Okay, Mason, can we solve this subtraction problem sideways like this in our heads, or do we need to regroup and set it up and down? Look at it, do we? Look at those places. Look at the ones place. Look at the tens place. Are we going to end up having to regroup? No. Confidence. No. You see here how your voice goes up at the end? Be confident. No. Oh, your voice is still going up. Make your voice go down. No. You're still going up. Come on, work on it. Work on it at home. Okay, so let's subtract the ones. Mason, 8 minus 6 is, you can use your fingers. Don't worry. Don't be nervous. 2. Now subtract the 10. 6 minus 4 is 2. Confidence, Mason. Bring down our dollar sign. So Mason, $68 minus $46 is $22. Are we done? Do we have one number on one side of our equal sign and a variable on the other? Yes. So Mason, sorry, mute yourself. So Mason, n equals what?
$22.
Which means, class, how much did the jeans cost?
$22.
$22.
Okay, look at your homework. Don't worry about the back of the independent practice. Don't worry about it. Look at your homework. Nope, don't worry about it means don't worry about it.
Don't do it.
Look at the homework. You are doing the same exact thing for each of these problems. Numbers 1 through 4 are just like all the independent practice we did, where you need to read through, figure out what the question is, figure out where the unknown is. Does it say something like a total of blank as one of the last sentences? If it says something like a total of blank, then you know, where does that number go? Does it go on the left side of the equal sign or on the right side of the equal sign? Colin?
Right side of the
The right side of the equal sign. If you don't have something like a total of blank, what does that probably mean? Where is your variable? Is your variable on the left side of the equal sign or the right? Zadie?
On the left. On the right.
On the right. If you don't have something like a total of blank, then your final answer to the equation is probably your unknown. If you do have something like a total of blank, that means you know the final answer to your equation, so your variable is going to be part of that equation. So be looking for those patterns. Be looking for things like, are you trying to find how many they won in a certain number of weeks or years? Well, then that means you need to find out how much they won in 1 week or 1 year they did or whatever. Practice, won, whatever. Okay? Or is it something like the doggy daycare question? Where they typically, not every single time, but mostly going to see similar situations to what we saw here. Just maybe a little different. Like the situation will be different, but you will probably solve most of them, maybe not all of them, the same way. Okay? So be looking for the patterns that we saw in our independent practice when you do your homework. Okay, then there is a vocabulary check, so make sure you're getting the vocabulary correct. And then there is a test practice. That test practice question, let me make sure it's the same.
Yeah.
Yeah. That test practice question is just seeing, do you know how to write an equation correctly? You don't have to solve the equation. You're just figuring out which of these equations is written correctly. Do you understand? So the major thing this lesson is trying to teach you is not how to do the math. It's how to write the equation. Does everybody understand that? What this lesson is really trying to teach you is how to write an equation, because you already know how to do all this math. We've been doing easy math almost all day. Like we did this like 2 chapters ago. But they want to know, can you write an equation? That's what we're looking, that's what the math book, that's what I'm looking for. So just pay close attention, read closely. Some of you are on it. Don't get scared just because I'm not here, okay? Some of you had an answer before I even prompted. Don't let it scare you just because I'm not with you. Because if you knew it before I even prompted to the right answer, you know it on your own, okay? You can do it, I promise you. You just need to slow down. Don't try to rush through this homework. All you have tonight is this homework and a reading log. So do not rush through it. Take your time, really think about it. There's only 6 questions, and one is a vocabulary. The other one you don't have to solve, you just have to choose the right equation. Yes, Colin?
And don't be afraid to ask your parents.
Don't be afraid to ask your parents, but make sure that you have done everything you can on your own, okay? Because it's probably been a very long time since your parents have had to write equations. So they may struggle with this even more than you do. You may be able to teach them how to do it. Okay? So don't be afraid to ask questions, but make sure that you are really reading closely before you ask a question. Don't just look at it and say, I don't know, let me go ask. Because that's when the frustration comes in. Okay? Yes, Zari. Quick, because we got to go pack up.
What if they don't understand and we don't understand and we've tried our best?
You can understand it. If you do not, it's because you're not reading closely enough, because it is going to be very similar to all these problems we've done today. You can understand all of it. You just might have to work a little harder than you're used to having to work. Yes, Zadie.
But you have to be careful if you get stuck on the test practice, because you have to tell your parents, don't give me the answer, just prompt me.
Yes, and that's why I really want you guys to do everything as much as you can on your own, because sometimes parents just want to give the answer and move on, okay? Just like you guys want to get the answer and move on. They sometimes want to do the same thing. So you have got to go slow, take your time. You can solve this. Do not turn in a paper to me with blank answers. You can solve all of these. Go ahead and tear out that homework. Close your math book and put it to the side, and get out several pieces of paper.